Awesome.
Yep.
Great.
Yep.
Thanks. Okay. So, yeah, as John said, I'm going to try and help demystify this whole concept of of agents and what they do. I think everybody over here has used AI, chat or ChatGPT or Gemini or other forms of AI, and even maybe something that they know is an agent, but maybe you don't understand fully what an agent is and what it does under the covers. So sometimes you might be afraid about what the agents can do. The word agents can summon all sorts of thoughts in your head, and so I'm here to sort of help demystify what they are, so you have a better understanding of what the power of agents is, and take advantage of it, like I do. I can tell you that I use agents in various forms, uh, probably 15 to 20 times a day, if not more, in various aspects of my work. Not just coding, but also, editing and software and creating presentations and understanding what meetings are about and things like that. So agents are very useful for a number of tasks. Anyway, so let's get going with this. Let me just go to the next screen. So the agenda, which I think was probably shared earlier, is going to be roughly like this. We're going to cover, what chat LLMs or large language models are today, why I think that's not enough, and then we're going to get to the meat of the topic, which is what are agents and the whole concept of tools, which is what really makes agents powerful. And then we'll cover different kinds of agents. There's non-coding agents, which I think all of us may have used in some form or another. And then there's coding agents, which I use regularly, and I'm sure some of you out there also may have used them. But we'll get into more details about coding agents and see how powerful they are. And then we'll talk about custom agents. If you were to build the agent yourself, like what does that mean? Or if other people have built agents that you want to run on your computer, things like OpenClaw that have become pretty popular these days. And we're going to do live demos throughout this. I know there are demos written at the end, but I'm going to sprinkle them throughout the presentation as we go along. All right, so just some quick stats, and honestly, I just asked, while I was editing this PowerPoint deck, I just asked Copilot to update this deck with all of the latest numbers, and it went away, it did some research for me, and came back and say, okay, these are the latest numbers that it knows about in terms of chat LLM usage today. And yeah, it's ChatGPT has been the early leader in this and still continues to hold the lead, but Gemini has, of course, become very popular, and it's probably the second. And yeah, I think the number of people in the States, especially adults that are using LLMs, has exceeded the 50% mark, which is good. I think that's great. It used to be maybe 40% just a few months ago. So this is definitely increasing on a month-to-month basis. So I just wanted to maybe set the stage to explain how LLMs work. And some of you may already know this, but I think it's a good refresher because it does help understand later on how agents work and why, you shouldn't be too afraid of the way agents work. So how does an LLM work today? In very simple terms. And again, of course, in classic, modern day style, I asked Copilot to go and create this image for me. I gave it some information on what I wanted, and it created this. One of the tells over here is that you notice the resolution of this image is not perfect. It's a little blurry, and that's just sometimes when the Copilot creates images, they're not the resolution may not be as sharp as you want to. But the content was very well articulated, and I'm going to use it to explain my point over here. So, user enters a query in the text box in ChatGPT or Gemini, and those are converted into what I call numbers or embeddings. And you can think of them as, and what are embeddings? So they're essentially points in a multidimensional space. I think we all know what three dimensions are, but so what's a multidimension? So multidimension is three dimensions, I mean, points could be anywhere in space, but but those points could also be pointed to anywhere in space, right? So if you combine both those aspects, you get multidimension. So you can have a point here that's pointed there. You have a point also there but maybe it's going in that direction. It's going faster in that direction or slower in that direction. So all these things together make a multidimensional space. And what it does, it takes all of the words that that you could type in all of the letters and words and creates these numbers out of them. And the good thing about numbers is that you can apply mathematics on it. So that's why you do that conversion. And then by previously training a model on all of the words that are there on the internet, we have this massive model, and it's able to look them up and then figure out what the next word should be. So when you ask a question, it's essentially going to predict what the next word is going to be for the answer, and it's then going to go back to the start and put that again, run the whole sentence with that new word back into the model, and then add another word, and it keeps doing this over and over again, right? So you can imagine if you just ask, if you ask a question that has maybe 20 lines of or 30 lines of text, it's probably gone through this whole routine, 100 times, right? So it's very powerful what this stuff does. It also takes a lot of CPU and GPU power, which is why there's so many demands for data centers around the world for AI, because this just requires a tremendous amount of computing power to do this. But it's also very powerful. Okay, so I'll just pause over here. Any questions so far before I go ahead? Okay, great. All right, so that's just a quick primer. As I said, I think most of you already know this, so not going to dwell too much on that. So what can chat do? It can, it can tell you. I think we've all used this, like, hey, we're on Excel, how do I create a spreadsheet, or how do I format it, or how do I, draft an email for me to my employer saying something or whatever. And then you have to copy paste it into your email box, right? Or, if you've got some code that's not working, you can ask, hey, what's wrong with the code? And it's going to tell you, okay, maybe you should change this line, maybe you should change that line. So it's going to tell you a bunch of things, or even suggest what a presentation should say, right? If you gave it some idea. But generally, those chat systems, they can't actually open up Excel and create the spreadsheet for you, right? They can't actually go into your email and send the email. Or they can't run the code and verify that it works. So there's things that it can do, which is tell you how to do things, but it can't do them. It can't do those things by themselves, right? That's really the kind of one of the limitations of chat. And so, yeah, I mean, we'll just go to a quick demo chat. I think most of you guys have already seen this, but let's just look at it just for completeness sake. For example, you can go in chat. I'm using Copilot, by the way, and you can see over here, I previously asked how to visualize how LLM works, and that's the diagram that you just saw. But I could ask, what is the latest meeting of the BCUG of New Jersey? Okay. And so, you can ask these kind of questions. Now, one of the things that it does is you'll notice that it provided a very current answer, right? And I previously mentioned that these LLMs, they were trained with information from the internet. And typically the training is, a few months behind, because training an LLM takes at least 20 to 30 days running on 10,000 computers, very powerful GPU computers. So, it's not something that's done too frequently. It's done, at maybe every few months or something like that. So the information in the LLM itself is typically a few months old. However, you saw that it actually provided a pretty recent answer here. And the reason this works is because when you used the modern chat, I think even Gemini, I think ChatGPT and all, they combine web search with the LLMs to provide the most current information, right? So that's what it's doing here. And did a web search. It gave the LLM all of the web search results, and the LLM just processed all of that and provided the answer that was most relevant. So this is where you see the combination of web search and chat LLMs.
I noticed that even though you spelled meeting wrong, it understood what you meant.
Yeah, that's a very good point. I did spell it wrong. Yes, I always get some of these letters in the wrong order, and it does. Even OD is wrong. Come to think of it. Now, one thing I did, I remember trying this before. I don't know if anyone's tried this, but I believe there's other clubs out there with the acronym BCUG, which is why I said of New Jersey. I think in the past when I tried it, it did confuse me with another club. I don't remember which one now. But yeah, so anyway, so that's just kind of the basics of chat LLMs, right? You can ask it various things, let's go back and look at over here. This was the diagram some of the things that it created. It actually created multiple versions of this diagram in terms of how ChatLLM works. This one was a little too technical a detail, so I actually told it to create a less technical version, which is what you saw over there. Okay. Anyway, so let's kind of go back. Yeah. Oh, another thing I wanted to show you, which is, when you saw this, when you saw me answer this question, you notice that these results came pretty fast, right? They just came on the screen like as if it was ready to go. But like I said, each of these letters, these words, is sort of processed one after another, right? Through that logic that I told you earlier, where the LLM has to kind of predict what the next word is. And this is happening very fast. But we can try and get an idea of how this works, by looking at something a little slower. So I have a local model over here, which is a Phi Mini 3.8B. It's running on my computer, this model. So this is not going to the it's not going to the it's not using the internet powerful large language models, using a large language model running on my computer. Okay, it's a Phi 4 mini model. So let's try asking a question over here and see how it works. So when was the Linux invented? Okay, it's going to take a little longer because it's running on my computer. Right, and this model I think is about 6 or 7 gigabytes in size. It's a mini model, so we'll see how the sort of results come up here. You can literally see it doing word by word here, right? It's kind of coming it's pretty fast still, but this is what it's doing under the covers. It's actually predicting what the next word should be, and that's why you could actually see the words being spit out over here because each word had to be processed by the computer one at a
Uh,
time, right?
Sujit, you say this is local.
Yeah.
What do you have a GPU? Is this a laptop with a GPU?
Yes, good question. So I do have a laptop with a GPU, but what I found out is that GPU can only be used for graphics. It's not cannot be used for like general purpose computing. I did monitor the GPU when this was running, and it's not using the GPU. Now I do have a gaming PC as well, and there when I run it, it's a lot faster because it actually uses the GPU. I also have a Mac Mini 4, and there too it uses GPU. But this one is a Surface Studio, and it doesn't use the GPU in at least in Olama. I'm using a tool called Olama over here, which is a popular tool to run local models, and it does not use the GPU in my computer. Have any of you tried running a local large language model?
I'm running, I've run several.
Yeah, which ones are you running? I figured.
Uh, I've I've run a few of them currently.
It's okay. Your voice is a little soft. Can you just?
Oh, I'm sorry.
Yeah.
I took my microphone off. Sorry about that.
No problem.
Gemma 4 is the one that I've
Yes,
been more or less sticking with
I
just
have it
because it
here.
fits comfortably into my NVIDIA card, which is I fortunately happen to have a 16 gigabyte or uh, a 12 gigabyte NVIDIA card that I bought a few years ago, a 36 RTS 3060, and it
Yeah.
so happens that that card in just by pure luck happens to be one of the best cards for running best cost to performance cards for running large language models these days.
Yeah, yeah. I think that's what I have in my gaming desktop as well. I have the same one, and it does.
Yeah,
You're
if
right.
you
It
have
does.
a 3060,
Yeah,
it's in relatively inexpensive and
yeah,
ideal.
yeah. And it
Uh,
allocates. It takes full advantage of the memory in the GPU, and it runs pretty fast. Yeah. So I did try Gamma 4, and I think Gamma 4 is Gemma 4. Is that how you say it? No, I said Gamma, but Gemma
I
4.
I
So,
don't know
Uh,
so
which pronunciation
the
is
thing
correct. I
here,
thought it was Gemma, but I
yeah.
don't know.
the
That's
thing
just a
here
guess.
is that you're running this on a laptop that does not have a GPU supporting this, which means that anybody could run Olama and an
Yeah,
appropriate model.
yeah.
They don't need
And
something special.
and that's why I selected the Phi 4 because it's a smaller model. It's a little less CPU intensive. Gemma is also, we could also try a similar question. I think I maybe had tried this. Oh, yeah. Let me just try this. Let me,
NVIDIA cards today have the best GPU support for large language models. There is support for some of other cards, but it's certainly more tricky to set up. But people have done that. But
Yeah, it
obviously
works on
not every piece of graphics hardware will support running large language models.
I think I ran it on my Mac Mini M4 as well, and whatever GPU is in there, it does run. Yeah.
Mhm.
So I think Gemma 4, if I recall, it may just take a while because it's probably the first time I'm asking the question after a while. But I think the response, if I recall, was much faster. Like once it starts spitting out the words, stuff comes out faster. Let's just see how long this takes. And what are the advantages of running a local model? And I think I've seen recently that local models, oh, actually, I think because of the CPU, it's still constrained, so it is still doing it word by word. But one of the advantages of having the local model is that you don't send anything to the internet. So if you're somebody who is concerned about privacy on the internet and all that, this is probably the best approach for you. It's a little slower, but everything's in your computer. You have control over what happens. And so this is certainly an option for everything that you do, even running agents. When we get to it, you could run agents with just a local model, and it'll just be a little slow, but it's perfectly possible to do it. Okay. So anyway, so everybody gets. Yes, Andy.
Where does the information come from that you populated your LLM?
So yeah, so previously, so let me go back here. So if you look at here, right? This is sort of the same pipeline is happening in your computer. You can think of it, right? It's just obviously runs a little slower, but um, this in the middle, this box over here, box 3, it's looking at all these nodes to do various mathematical calculations, and it's looking at some numbers, right? It's looking to see, okay, I'm going to take this number, I'm going to perform like a 1 divided by 1 plus some sigmoid function. It's going to apply them to the numbers. But those numbers were previously calculated and trained based on the entire internet, right? Or whatever information was there on the internet. Now, obviously, all of the information on the internet is going to be too big a model, and that's why you can't fit that in your computer. These mini models that you see, like Gemma and Phi, they take sort of the most relevant, the most popular, the most important parts of the internet and have kind of shrunk it down, right? That's why the models are smaller. So, but all of those numbers are still pre-calculated and they're in the model. And those numbers represent everything of importance to the internet. So when you ask a question, it's basically going through like a matrix to figure out what the next number should be, and that number maps to a word. Just like a word maps to a number also maps back to a word. So 2 goes to 3, but 3 also goes to 2. Does that help, Andy?
Yeah, I'm just shaking my head saying, wait, it's nothing like what I thought it was. It's not like you need a local repository with all kinds of information. A sophisticated indexing system.
Correct. Yeah, absolutely. That's a very good way to put it. It is a very, very sophisticated indexing system. Correct.
Right, but the data that it's indexing is out on you're left with the index phone, but what was indexed is out on the internet.
Correct.
No, you loaded a model locally. You loaded a 5 was a 6 gigabyte model or something?
Yeah.
You loaded the model onto your computer. You can disconnect your computer from the internet and ask those questions through Olama to Phi.
Right. But I think what Andy is saying is correct, John, is that model was previously generated with information that was on the internet. So when that model was trained, it was trained, in some web, like maybe using 20, 30.
At this point, there are hundreds of little models.
Yeah. And all of them have been trained on various parts of the internet. There are some models that are trained only on, graphics terms, and some models are trained only on gardening terms or whatever. But it still was trained on what was available at the internet at that time. And then once it's trained, that index, as Andy calls it, is combined into the model, and you download it and you run it locally. So both of you are correct, but I just want to clarify there's a difference in your perspectives there.
Thank you.
I found it very, very illustrative to generate some elementary code in Python with an LLM
Yeah.
to actually play with the protocol to convert to send messages back and forth to the LLM so that you get to see all the bits that travel between your front end and the LLM itself.
And I've got a demo on something similar to that later, Sergey. So when we talk about agents, so yeah, we'll take a look at that.
I imagine that local LLMs, running local LLMs will give you a better position on copywriting the material it generates.
Yeah, you have to look at all LLMs have what is called, I think it's called a card. What is it called? It's called a model card. Okay, so every LLM, if you go to Hugging Face, which is a good sort of destination or directory of all the LLMs out there, and there are tens of thousands of LLMs, each one has something called a model card. And that model card gives you a lot of information about how the model was created, how accurate it is, what sort of guardrails it has, and what the information in there could be expected, like whether it's going to spit out profanic words or not. All those things are kind of listed in the model card. So that's where you want to look to see if you're worried about what's in the LLM is the model card. So anytime a new model is released, is always, if you go to GPT, the OpenAI website or the Gemini website, every time they release a model, always have a model card. Does that help, Gilbert?
Yes.
All right. I'm getting some background noise, so if you don't mind, I'm just going to.
I think that's Gilbert.
I'm going to mute you, Gilbert. Okay. Okay. All right. So we did a quick demo on chat LLMs, and we know what the limits are. You can ask questions, but it actually doesn't do anything for you. So this is where agents come in the picture, right? So what are agents? So agents are taking the concept of LLMs, the very same concept that you just seen. Nothing, like I said, there's nothing new over here. The LLMs aren't doing anything different, but we've taken the concept of LLMs and extended it out to do something useful. So agents are things that that will think about a goal. So when you ask the LLM to do something, ask a question, now you're going to give it some additional context, like, I'm trying to achieve this goal, right? So it's going to come up with a goal. It's going to figure out how to get to that goal. It's going to come up with a plan to get to the goal. What are some of the smallest steps? Because, when you think about, I'm going to ask an agent to do something for me, to do something interesting for me, it could be something complicated, and it may be something that has to be broken out into smaller pieces, because LLMs are powerful, but they can't do magic, right? They can still do small things at a time. And so oftentimes you have to take a big task, a big goal, and break it out into smaller tasks. And then there's sort of memory that's involved. And memory is for something for it to remember as it's going from task to task, right? So it's created this pipeline of tasks that it has to do. And as it goes from task to task, it needs to remember what it did previously so that it doesn't have to go back and redo it. And so that's where memory comes in. But the most important part about agents is something called tools, right? So tools are the local sort of extensions that allow the agents to do magic for you, right? They are the ones that allow you to make changes, to update things, to maybe even delete things if that may be, right? But tools are the big thing. And I want to, so that's the one focus area for the rest of this presentation, is going to be, about the tools and what tools are available to us as we use agents. Okay. So what are these tools? I'll give you a few samples of them. So obviously the web browsers are tools, right? You might want an agent to go, read the internet or read your favorite, GitHub website or whatever, GitHub repo, and do something from there, right? Or maybe you want to go and fill your taxes online. Fine, okay, the agent can do that too, right? It needs the web browser to do that. File systems, hey, maybe you can read files, you can also write files, you can delete files, organize them, whatever, right? That could be that's something an agent could do. That's another tool. Running code, we talked about that. That's nowadays that's pretty popular. The agent can actually run some code. In fact, running Python code, as Sergey said, is very popular with agents. Agents love to create Python code and run it because it's a very ubiquitous language. It has a lot of features in there. It can do a lot of things. And so Python is often a good destination for agents. Office APIs, specifically if you want to get something into Excel or Word and do something out of the covers, being able to do that, you know, as an extension of the LLM is very cool. We'll see some examples of that. And then there's image tools. And image tools, we've all seen, I think, Bill and others have given presentations on the power of image tools, how, they have these new modern image editing tools which use AI to help, kind of make changes to images and things like that. So these are all sort of the extensions to the large language model. They are using tools to do local things, right? They give you the hands to they give AI the hands to do something for you. Any questions so far?
Uh,
Okay. So I want to start by showing you the most basic agent ever, right? And I kind of wrote this thing I used the AI to help me write this little Python code, but I think it illustrates very, very succinctly what an agent is and how it uses tools. So I'm briefly going to switch over to Visual Studio Code, which is my favorite editing tool. And a simple Python application here, but I don't want you to get distracted with some of the other things that are in here. The main thing is that you guys are all familiar with the concept of prompts in LLMs, and I want you to focus on the prompts over here, right? The system prompt, as we all know, whenever you talk to an LLM, you give it like a system prompt and you give it an actual user prompt. Right? System prompt is kind of just defines what the scope of that agent is. Kind of gives it the flavor for the LLM. Tells the LLM, hey, I'm going to ask you a question in this particular context, right? And so the context you're going to tell it, we're going to tell the LLM that you are a careful image dedupe agent. Oh, by the way, the purpose of this agent is to delete duplicate images in a folder, right? I think we've often talked about this problem that, we have hundreds and thousands of images on our computers, and some of them are duplicates, and you need to clean them up. And, yeah. So I figured I'm going to make a very simplistic version of it and ask the LLM to create an agent to delete it for me using the LLM. Okay. So that's what we're doing over here. So we're telling the very simple system prompt, hey, you are a very careful image dedupe agent. Careful is a very important word over here because we don't want the LLM to go too rogue or wild on us. Now, and it says this is the most important. Use available tools to deduplicate images in a folder, right? Very important thing. Use available tools. So what are the tools that are available? We're going to give it a list of tools to do work for us. One of the tools is list image files. It clearly says it gives the list of image files in a folder. For example, if I were to ask, to build to actually do this work, right? To create to actually deduplicate images in a folder, right? What would you do? You would first get all the list of images in the folder. Then you would look at those individual images to see which ones are duplicate, and then you would delete the duplicate images, right? That's pretty kind of normal function that you would do. So the tools that you need are three tools. You need a tool to list all the images, you need a tool to get the contents of the image, and you need a tool to delete the image. With those three tools, the agent should be able to do whatever, like deleting those duplicate images. So we've got three tools: list images in a folder. The second tool is to get the file content of a particular image, right? And this is the description of that tool. And the third tool is to delete the image. Okay. So there's three very simple tools that we have. That's all we have, three tools, right? And that's all we have to give we have to tell that's the only information we have to give the LLM. Let me just close this up. Let me just go now to the point where we actually call this. Give me 1 second. Yeah, I think it should be an agent.py. If we go down here, and I want you to ignore all this stuff because this is all yeah. So the only thing that we're going to tell the LLM to do is to deduplicate the images in this folder. And we're going to give it the name, the folder path. Now, can you imagine? This is the only thing I am telling the LLM, okay? Deduplicate images in this folder. So how is the LLM going to actually figure out what to do? You can imagine, I'm going to ask ChatGPT, deduplicate images in this folder. ChatGPT can't do that, right? So how do you think this is going to work? How do you think that just telling the LLM, telling ChatGPT or Gemini to deduplicate images in this folder, how is that going to translate to actually deleting files or finding files on your computer? Anybody want to take a guess at that or try to hazard a Sergey might know the answer, so feel free to answer, Sergey.
Checksum. Checksum.
I'll keep my lips zipped.
How
Okay.
does the LLM know that the tool exists?
Great. So we did give it that system prompt. So like you saw the system prompt earlier, right? So that was the system prompt which said, you are a careful tools agent and tools LLM, and here are the tools. So I've given it the list of tools, right? But here the instructions to the LLM is just deduplicate images in the folder, right? I didn't tell it which tools to use. I'm just saying here are the bunch of tools and here's a task. Go figure it out, right? That's what I'm telling it. That's the beauty of this whole system.
I
I'm
think
just
what you're looking for, John, is that there is a well-established tools protocol. That is the ability for the model to be told what tool exists. Here is a set of tool functions. Here is a set of parameters that you pass to them. And the model understands this and is trained to go and figure out when it needs, as part of its plan, to go invoke each function that the tool provides.
Now,
And that's the
are you
basic loop.
telling the model or are you telling Olama?
You're telling the model runner that these tools exist and it supplies this information to the model, and the model is trained when it develops the plan for, in this case, deduplicating images. It will develop a plan that says, give me a list of files. Now now for these files, give me the contents of each file, and it will identify, or a hash of each file, and it will identify the duplicate hashes, and then it will select the things that are duplicate that need to be deleted and invoke the tool to delete them.
Okay, so
Correct,
Sujit, were
absolutely
you
correct.
going to show us how the tool
Yeah.
gets connected? What are the pieces
Yeah.
that are involved in
I'm going to show you. I'm going to show you it running and to see that back and forth between the LLM, right? So you know how that works. But
But somehow you had to tell something that this tool exists.
you have to give it a list of tools, right? And so one of the key things over here, and when you create these tools, right, is this description field, right? This is the field that is the most important in any tool, right? It's a plain English description of the tool. Remember, one of the things that LLMs do very well, I mean, that's what has made them phenomenal. Always think of LLMs in this particular context, right? They understand language very well, language semantics very well. That is what they are excellent at, better than anybody else. Okay. And so just knowing that this tool can list images in a folder is enough for them to know when to use this tool and how to use it, right? Of course, below this, there's a well-described protocol, as Sergey said, right? Okay, this is the folder path and how you can pass the parameters and all. But remember, the LLM cannot actually execute any tool for you, right? It's only going to know that these tools exist. You still need an agent locally to actually execute these tools for you. So let's look at the thing running, and then it'll become more apparent. All right, John?
Can you show us where you connected this agent.py to Olama and the model?
So I'm not using Olama over here. I'm using just an open AI model, ChatGPT, but GPT 5.4. Okay. And again, I don't want to get distracted with that part of it because there's a little bit of, Python code involved there, which is not important to this demo. Okay. I can show you that later, but just remember that this is actually going to be plopped into a ChatGPT window and you're going to get some results back. Think of it that way. Okay. But the question is, what are we going to do with those results, and what comes back, and what do we do with that, right? That's the whole problem. That's the whole thing that we want to figure out. Does that help, John?
Yeah.
Okay, so let's actually run this. I have a window here that is running it. I'll make it a little bigger here. Okay, and so let me just make sure that so I have some sample images in a folder called images. So if I do dir images, is this terminal window big enough for everybody? Do I need to make it bigger?
Yeah.
Okay. So you can see there are 7 images in this folder, and there are 2 of them that are duplicate with 2 duplicates. So there should be 5 unique images over here. All right. And so we're going to run this thing. It's a simple Python program, like I said. And so, now, when I wrote this program, you see, I'm going to run this main.py, and I'm passing it 2 parameters, an execute and a transcript. The transcript tells you that we want to see what it's doing. Execute is a very important parameter. So anytime you have an agent, right, you don't want to accidentally execute or call an agent, because agents are going to do something that could potentially be destructive. In our case, it is destructive. It's going to delete files, but you don't want to accidentally do it. And so that's why you always be specifically call out the fact that I want to execute this agent. That's why we have this parameter here. So I don't accidentally run python.main.py and have all sorts of problems. And then this last parameter here is the images folder. That's just a folder name. Okay. So we're going to run this. And John, you bring up a good question. We could try running this again against Ollama and see what happens. I didn't think about that when creating this demo. For now, I'm using an OpenAI model to do it. Let's see what happens. Okay, so here's the prompt that we just talked about with all the tools, and it's running the prompt. It's waiting for response. Okay. You could see pretty much whatever Sergey said it did, right, in that correct sequence. And you could see that it's done. It deleted 2 duplicate images, and it said images, and it kept 5 unique images in the images folder, right? So kind of it did the work that we wanted to do. But we didn't actually write the code in the Python application to do to look up duplicate files or do anything. The LLM told the Python code what to do. That's the definition of an agent, right? So let's go back to the top of the screen here and see the flow. I think that'll help. So we started up over here. This was the original prompt that we talked about with the 3 tools, right? And when we send it out, here's what came back. The very first thing the LLM said, hey, can you call list images for me? List image files for me, which is what we expected. The LLM would want to know that. So the local agent went and called the list image files and said, you wanted list image files? Here you go. Here's the 7 files that I found. Then the LLM is going to come back and say, okay. And this is where we return it back to the LLM. Now the LLM is saying, okay, for each one of those files, can you get me the file contents? Exactly like Sergey said it would do. 1, 2, 3, 4, 5, and it made 7 tool calls, right? It just truncated over here, but it did 7 tool calls, 1 for each file. Simply call the tool 7 times, get me the file contents for each of the files, right? And we get it the file contents. In our case, we're just returning the hash code for each file. We return it back to the LLM. You can see I'm returning 7 hashes back to the LLM. Okay.
Okay. Yeah.
Now the LLM has the 7 hashes of all the files in our folder. And now the LLM is going to double check to make sure that it deletes the right file. This is how we tell it to be a careful agent, right? It's once again asking me, oh, can you list all the files again for me? It wants to be very careful that it's deleting the right files. So we gave the list of files. It says, okay, now delete these 2 files for me. So it's telling us which 2 files to delete for it. We deleted files. Then it says, oh, can you provide me with a list of files again? And now we provide a list of files, which is only 5 files. So now it knows for sure that I call list files. I had seven images. I told it to delete 2. I call list files again, and there were 5. So it did the job correctly, right? That's how it knows it worked. And it says, okay, I'm done. I deleted the 2 images correctly. This is how it knows that it did exactly what you asked it to do, right? But you notice that we didn't really tell it that sequence. I mean, Sergey, is an experienced person. He knew the sequence. All of us could have figured out what that sequence of steps is, but the LLM just figured it out just by us giving it very vague instructions, right? No, delete the duplicate files from my computer, right? And it just figured out what tools to use, figured out the right sequence, how many to call, when to call, and it worked, right? So this is what I mean by how an agent works, right? The LLM is just returning instructions back to the local uh, program, which is the agent, to do work on its behalf, right? Because the LLM cannot reach into your computer and do things. It needs something locally do, and that's what the agent does. I'll stop
Oh,
over here to see if there's any questions.
Sergey raised his hand.
Oh, sorry, I couldn't see the hands. Yes, sir.
Yeah.
You might want to scroll through this and just point out the role fields in each one of those returns.
Yeah.
So
Tool.
the agent has multiple different roles that it performs based on what the LLM requests, right? And the LLM will ask to use a tool, or it will provide a result, or it will act, or it will show the user information. It'll act as an assistant, right? So in particular, the role tool returns from the LLM are the ones that say, hey, don't return this result to the user. I need you to go call a tool. And that's what the agent program does.
So
Yep.
you gave a command to the large language model, to the chatbot, and it was connected. It knew about the agent because that was in what you gave it.
Well, here's the role user is the one that says, here is the user request, right? And then an assistant said, well, here are the available tools and I can call a tool. And then it says, hey, I can call a tool, give me a listing. And then once it got the listing, then it knew to call a tool to get file contents, in this case, in file names and hashes.
So you, the user, made a request to the chatbot,
to the agent.
to the
And the
agent.
agent sent
No,
it to
wait,
the model. The model
and
came,
then they went
made
off like
several
an
requests.
assistant and did work in the background and then gave you the final answer.
Well, it's the agent that knew what the model wanted, whether it wanted to a tool run or whether it wanted the results to return to the user based on the role field in the results that were returned from the LLM.
Yep. So if you go right to the end over here, right, if you look at this, you can see this is the final where the role the assistant
role
says, okay,
assistant,
I'm
right?
done, right?
And
This
all
is
the other ones before were tool calls.
Yeah. It says
between
I'm
the
done.
original prompt and the result. Right? So what you had was an original user request with a role user, an original system prompt with a role system, and then a whole bunch of responses from the LLM that said, here, go use a tool. And the agent went and did that in a loop until it got a response with the assistant role that, hey, give this back to the user as an actual result.
Did you have to give when you started this, did you talk English to?
Yeah. So the English was very
not Python.
No Python. As I said, just forget about the Python. The Python is just the implementation of the agent. But what really is important here is we gave it a very simple English request, which is right down here. I want you to ignore all these other things, right? These were just set up. Where was that?
All of this is a text protocol that takes place most likely over HTTP.
Right.
It's just text messages going back and forth, specifically JSON chunks.
This is the only request we gave the LLM. Okay, from my perspective, like as a user, I said, hey, go delete these files and delete the duplicate images. That's all from this folder. That's all as a user, that's all I did. Okay. But under the cover, the agent that I had built, right, was familiar with, okay, I have these tools at my disposal. I'm going to give the tools to the LLM, tell the LLM, hey, I have these tools available to me. Can you execute? Now, if I were to, put something else over here, I were to say, I don't know, what is the delete all my files in the C root folder. It wouldn't, probably wouldn't be able to do that, right? Because it doesn't really understand. There's no clear instructions, no tools available that lets it delete willy-nilly files. Does that help, John?
Well, I'm still
Let me
drowning. I'm still drowning in too much Python code.
Yeah. As I said, don't ignore the Python code. That was just the implementation of the agent. I have a diagram for this that
It's the JSON that you saw in the output that's really relevant.
yeah. Let me see.
Right.
I did create
I mean, I'm sure that I could have some model create all that code for me, but
which
then
is correct, yeah.
I just want to have a place where there's a place where I type in delete the duplicates in the folder so and so.
Yeah. Right. So this sort of helps you hopefully understand. So in this main Python file, right, we just took that request, that basic request, right, and send the prompt to the Azure OpenAI, and it got the Azure OpenAI simply came back and said, "Hey, call list images," right? Then we get all the file contents. Then the next one was to get the file contents, and he added to the tool and he sent it back. It executed the tool. Then you execute the third tool. So it keeps going in this pipeline. You can see it goes like this, like this, like this, and like the zigzag. It goes like in a back and forth fashion. But each time, right, all you're doing, you're going back to the LLM, you're going back to the LLM, you're going back to the LLM each time to go, what is my next task? What is my next task? What is my next task? Eventually, the LLM is going to say, you're done. I have nothing else to do. It's finished. The job is finished, and it's going to stop. John, well, you seem to be concerned about the amount of Python code. Is that where your concern is?
Yeah, like I think I see that you are running this in Visual Studio Code.
Yeah, I did. Yeah,
And you're connected to a large language model that's running on
in Azure. Yeah,
Azure.
yeah.
And so if somebody were to walk up to ChatGPT in the browser,
You couldn't do this. No. So you couldn't do it.
There is no way to pass the tool information to ChatGPT.
Yeah. And even if you did pass it to it, there's no way that the ChatGPT could do anything with it. It would just come back and say, oh, maybe.
So what is the thing that's necessary here that moves you from ChatGPT to a structure that I can connect to this stuff? The browser with ChatGPT all by itself is not sufficient. You said that. The large language model.
Okay.
Boom. We're
So
live.
I do have one question, Sujit. I
Yeah.
presume that your main.py calls agent.py. Is that what's going on here?
Yeah, that's just normal
All right.
Python code. Yeah, main.py,
Okay. All right.
agent.py, and then I think there is a tools.py, right? So it's a good question. So if you want to see what these tools look like, we talked about the definition of the tools. And what do the tools actually do? Yeah, there's some Python. There's very simple Python code here. List image files. It's just using the simple Python of, I think
Okay.
it's the path thing to get all the list of files, and then it kind of formats them in a nice way. It sorts them and whatnot and returns them back, right? Getting the file contents, same thing, right? It uses the file read command. It creates the hash of it and returns the hash, right? And
Got
then
it.
deleting the file, it's right here, right? It just checks the file and then it where is it? Yeah,
Okay.
it just deletes it. Yeah.
Well, but the key thing is that the LLM doesn't know anything about how the agent executes the functions.
Right.
LLM just knows that these functions definitions exist. Here's what they do in human language, as the description says. Here are the parameters that the LLM needs to pass back to use the tool. And then the LLM just tosses back a chunk of JSON that says, call this function, this tool function that you promised me that you have. and it expects to be returned back the relevant data.
All right. So,
Right? How that's implemented is just mechanics.
okay. This may be a fundamental question. So basically what you're doing is you're passing all this Python code to the LLM. Is that part of what?
No. The
No?
LLM doesn't know anything about the Python, anything about the implementation. The only thing that gets passed to the LLM is a piece of JSON that says these functions exist. And here's what you can expect them to do, and here's the parameters that it needs. And the LLM says, oh, well, in my planning, I've figured out that I need to call this tool function. Here, agent, call this tool function for me because you promised that you can. The agent figures out that this is the tool function that needs to be called because that's what the LLM requested, and it calls the function. And then it sends the results back to the LLM appended to all the previous information that the LLM got.
I got to think about this. Yeah. I'm slow.
So
learner.
it's literally the conversation that's going back and forth between the agent and the LLM. So it starts with the initial user prompt, and then there is an exchange back and forth between the.
All right. So I think we tried to get further clarification on things, but let's go ahead because maybe
Yeah, move on. Yeah.
we'll see some of the other ways. I just want to show you like what a basic agent looks like, and essentially the Python code that everyone's concerned about here. So this is what the implementation. Any agent that you use, you buy, or you download, right? Anything that says agent is going to have all this code in it already, right? It's going to have a way to call a model. It's going to have a list of tools, and essentially you can ask it to do some function, and it's going to tell the model, okay, I have got these 20 tools with me, and this is the user request. What do I do? And the model is going to create the plan. It's going to say, okay, call this tool first, then call that tool, and then call that tool, and you're done, right? And so that's what any agent would do. I simplified it as much as possible with a very simple agent.
Okay.
So we can extend this and see like some non-coding agents, what they can do. I think we could take a quick look at a Word document for like a Word agent. Let's see what that does. This is using the agent in Word. Uh, so this is the file. Let me try and make this bigger. Yeah, this is the file. It's the things in a cemetery. My son at one time he had cleaned out a cemetery that was close to our house over here, and made all the gravestones. It's a very old cemetery. Made all the gravestones visible and whatnot. So we had a record of them. So you could kind of go in here into. Of course, this is what you would normally do, is to kind of ask what is this doc about? Right. So this is kind of some of the simple things that you can do. And it kind of tells you, sort of, you could, of course, summarize, you could ask it to summarize some of the key names, family names of this thing. The Walling name is very popular in various cemeteries in this part of New Jersey. So you see that a lot. And there's some other names that were also there. Anyway, so this is kind of something, if you just wanted to ask it to do, but you're not making any changes here. But if you do want to make something like, let's see, something new, right? And I can say, create a write-up about the BCUG of New Jersey. Okay. So I've given it a task to create the write-up about the BC unit, right? So it's going to obviously try and figure out this is the goal. We know what the goal is, and it knows what the tools are. The tools are essentially the tools that Microsoft Word is providing, right? Microsoft Word is told that, I have tools that I can write stuff to the document. I have tools that can make things bold. I have tools that can delete words. I have tools that can change the background color of things, right? These are all tools. They're all examples of tools. And now the LLM is going to tell Word, okay, what to do, how to run those tools. Essentially, that's what it's doing. It's telling Word to how to organize those tools, how to call them, and that's resulting in this Word document being created, right?
Okay.
So here the list of tools were provided by Microsoft Word. Microsoft Word provided the list of tools and it gave it to the agent, to the LLM, and told the LLM, the users asked me to, create a write-up on BCUG. And because the LLM looked up BCUG and got some information and then told Word how to format that information, right? So this is a very good example of, of an agent in Word. Any questions on this? Has anyone used this feature?
So
In Word?
this is built into Word now?
Yes, yes. In Word, if you put it in allow editing mode, it would do that for you.
Yeah, that's probably Word 360.
The Office, is that part of Office 365?
Yeah,
Okay.
yeah. If you have a subscription, you should have this feature.
Okay.
Yeah, and you can ask it to you can iterate over it of
Yeah.
expand more words, expand on this.
Exactly. You can change it. You can say
Reduce the word count
make
here.
it more technical in look and feel, like something like that. Let's see what it does now. So you see the plan, you saw the plan briefly there, it created a
Yeah.
plan, and now it's doing some research. So one of the sort of paradigms that has become apparent in agentic world is called RPI, right? Research, plan, and then implement, right? It's always those three steps. When you have a goal to get to, you first research the goal, then you plan the list of tasks or steps that are involved, and then you implement them. So it went through that RPI process, and it's tried to create something that's a little more technical. I don't know if I would call this technical, but it changed the.
So in this
It,
case, if you have Microsoft 365 and you open up your version of Word and you go to the Copilot icon in the upper right, you can enter this request and
you got to make sure you're in edit mode though, right? By default, it might be in chat mode. Just keep an eye on that.
yeah, and you can just say what you want and the topic, and Copilot will go out and get the information and hand it to something behind Copilot to create this and then use all of the features of Microsoft Word as an agent, telling it.
Okay.
So in this case, Copilot is the agent, and Microsoft Word provides all of the tools, right? And that's how I would think about it.
Yeah.
Copilot is a general purpose agent, but it has no tools. But now it's connected to Microsoft Word, so Microsoft Word is telling it, hey, I have got these 20 tools that you can use, right? And now Copilot is taking those 20 tools, taking my simple request and sending it all to the LLM and saying, go figure this out. The LLM is going to make a plan, come back and say, oh, yeah, I understand how this should work. You first use this tool to write out these things and then use that tool to write out those things and, so on and so forth.
You could also change the language, right? Suppose you say change the language to a different language.
Oh, you mean in like use Spanish or something like that?
Yeah.
Yeah,
Yeah,
we could try. We could try
Render
that.
in Spanish is probably the right words.
Yeah. Add a summary in Spanish.
Sujit?
Yes.
Okay, you have Copilot that works across the Office applications. Is
Right.
it a difference between, is it using the same LLM or is it using different LLM? There are tools for Word, there are tools for Excel, there are tools for PowerPoint. Are
Yes.
they all part of the Copilot toolkit, or is it each application has, I don't know if I'm explaining it correctly.
You
Each
are. You are.
has its own tools
Correct.
that go against a common LLM or individually. Is there a separate LLM for Word compared to
No.
Excel?
No, you could. So I'll answer this question in steps over here. So, first of all, Copilot is your general purpose agent you can think about, right? Like just your vanilla agent. It basically can do nothing other than be an agent. As we said, agent is only powerful when it has tools. And so in this particular case, because it's attached to Microsoft Word comes with a bucket of tools that can provide to Copilot and say, I have these tools, uh, available to me, and go ahead and do them. Now, the LLM that you call could be any LLM. As Sergey said earlier, it has to be an LLM that understands tool protocol. There's a certain protocol that's embedded in the newer versions of the LLM. So if you go back to a very old model of the LLM, there's a chance that that does not understand tool calling because it's just the way in the API in the LLM API, there's a separate section where you have to identify the tool. So that's the only difference. But generally speaking,
isn't that information commonly available in the model card also?
it should be, yeah, if it supports
I'm
tools.
pretty sure I've seen
Yeah.
it that the
Yeah.
model cards will
Yeah.
list whether it supports tool calling.
Exactly. Whether, agentic tool calling, whether it's there. Correct.
And the place that you can see these is on Hugging Face.
Hugging Face is just a way where everything is like all the models in the world more or less are aggregated. But if you want to see more details, you can go to the Gemini website or
If
the
you're using
OpenAI.
Llama for your models, Llama will have model cards as well.
Yeah.
Wherever you're getting your model, they're extremely unlikely not to make the model card available to you.
But the thing is that Hugging Face is one of the generic places on the web where you can go and look at most things. If you haven't installed Ollama or anything else on your computer.
On the Llama website, you can definitely see the model cards and the more model details. Either they'll have the actual model card or they'll have a pointer to the Hugging Face model.
Yeah. So let's see models.
So Hugging Face is a website.
Yeah.
And Llama has a website of its own with information available.
Yeah, you can see over here, this is typically like this opening page is typically like the card, which has all the performance, the benchmarks. It's a lot of technical information over here, including, some caveats in how it was created. That's just one of the models over here.
And one of the things that it tells you about the model is what they're trained toward, like coding or image generation or general conversation, right? That's someplace in here.
Yeah, I think
that's usually in a model description.
Yeah, you can see this is the model card, so that's where you always start, and then you can always go to the actual GitHub website where where the model which shows you some of the more details how the model was created, like the nitty-gritty details. But yeah, let me see. No region limits, about others. It shows you some of it's not a reasoning model, so the reasoning it's not a coding model, so that's blank, right? So some of these models are just specific use case for
I
them.
thought that those were categories of tests in that.
Is that what it is?
Yeah, I think so. I think reasoning is just a list of reasoning tests.
I think you're right. Yeah.
Benchmarks that they
I was looking at that wrong. You're right. These are all the coding it does. And there's the agentic ones here. So agent is also supported right here.
Yeah.
Good call.
By the way, there was a tool related thing mentioned down there in that table. So obviously this one is tool capable. I think on the last
tool,
decathlon
or whatever
pretty much implies that this is tool capable.
Yeah.
But that's got to be somewhere on this page though.
Yeah. You can also go to gemini.google.com and just use the Gemini API by just typing in the web page.
Yeah. Now I'm just saying this one sort of has all the models in the world, right? That's the thing. It's just very
Any on the web page, you're just using a chat interface.
All the gophers in the world.
All right, so let's move along now to I want to show you Excel, right? Because I know we have our Excel community that we use over here. In fact, I was getting ready for this presentation, and I remember this. Does anyone remember this spreadsheet that we had worked on with the Excel? It was, I forget, we did an Excel session over here where we were looking at this particular spreadsheet. Anyway, I think we were learning how to do Power Queries, and we created this. So obviously you can go in here again using this chat interface, right, and say, just gonna, I think I have it over here, right? Yeah. So let me just try this again. So what revenue insights can we get from the data? So, it's going to figure out, this is just normal chat, right? We were able to do before, which is just to query the data and get some insights from it.
But
So
the
let's see
thing
what
is that because it's built into Excel, it's able to read your spreadsheet, which if
correct.
you were sitting in ChatGPT anywhere, it wouldn't be able to read a file or anything.
You'd have to
Your
copy
file.
paste it. Yeah, you'd have to copy it from Excel and paste it into ChatGPT or something, correct? So let's see what it does here. And see now, because we're in agentic mode, it created a complete new, sheet for me, right? And not just giving me answers, it actually populated it in another sheet. So it's always there. The information is always there. If I change some of the numbers, it would change here. It's connected everything. It kind of, did it all. So everything's like just visible over here in one shot, right? Now, again, how does this work? Same thing. Excel told Copilot, hey, I've got all these tools with me. Yeah, go use them. And so Copilot is going to ask the LLM, okay, here are the list of tools, and here is the user query, and here's the data. What do I do? And it's telling it, okay, yeah, draw this graph over here and use these tools to create this cell over there and draw this chart over here and whatnot. Does that help? Have you guys used this part of Excel, like Excel in this way?
Not that sophisticated, but
So it's kind of nice. And,
so in terms of agents, Microsoft built agents into each of the Office programs.
no, the Copilot is a universal agent that Microsoft built. The Office programs are providing the tools.
So we're distinguishing between the agent and the tool.
Correct.
Did they have to modify Excel?
Yeah, to kind of light up those tools, so to speak, to make it such that it's easy for the agent to call them. So this is a standard Copilot agent on the right, and it's attached to this Excel. Excel has told it, hey, I have all these tools. And going back to our very basic program that we saw earlier, that's why I said the Python application was, the general agent with a set of 3 tools that was attached to it. And the question that we asked, which is what I asked over here in Excel, is, just deduplicate my files, right? My image files. And in my case, I have to, what revenue insights can we get from the data? That's all I asked. I didn't do anything else. And then the LLM's going to figure out, okay, I have these tools, I have this data, and I'm going to call these tools in the sequence and produce the results.
So you could actually ask it if there is any unique behavior someplace that needs a correction from all of this. So it could analyze your business if this was, and then it wouldn't give you pages and pages of report. It would give you some summary like that office is underperforming.
Yeah. You could say,
which product should I get rid of?
Oh, okay.
Yeah, see, it doesn't know that it's like, I don't know, I haven't looked at the Power Query. There's no products here, right? This particular thing has no such thing as product. So it didn't answer, he couldn't answer the question.
Anyway,
it's about
but you
custom.
could ask something like, which customer is costing me more? Am I not making a good profit on? Because there's a customer. But the thing is that with
Yeah,
these
right.
things, you
Right.
can see
Okay.
why people aren't getting jobs.
Yeah.
Yeah. Ah, okay.
Acme Grocery. All right, we're getting rid of
Right.
Acme.
Right. So that was a task that might have been given to a junior person in the company to figure this out, but
Indeed.
it just happened right away.
Yep.
Uh-huh.
And so one of the things it does, I know for Excel, I happen to know how this works, is I think we've all in the Excel workshop, we've all used the concept of formulas in Excel.
Yeah.
And really that's what the LLM is it's doing. It's telling Excel what formulas to apply automatically, right? In this thing. Because it knows that's a tool. That's a very powerful tool in Excel, is the ability to run formulas on cells or to run formulas across the sheet. And so it's using that, going to use that feature. The LLM's going to come back and say, yep, do this, do that in this particular sequence.
Fascinating.
I'm gonna try to shut up so that you can
Go ahead,
proceed
John.
with your agenda.
Yeah.
You had a question, John? Go ahead.
No,
Hey,
no,
Sujit.
Yes, Andy.
Sujit, there are some common words across the different applications. For example, format. If you're presenting something, there are different things that you could use or that you'd be interested in, whether you were in Word or PowerPoint or Excel. Does each application have its own version of formatting, for example, or is it a common tool to Copilot that crosses all the applications? I understand that there will be some tools that are application specific because they don't really apply. You're not going to calculate double declining balance depreciation in your Word document, for example.
Well,
Yeah.
I
Go
find the word render is very useful. Render as text, plain text. Render as HTML.
Yeah.
Render as a Word document. Render as PowerPoint.
And I'll tell you how it disambiguates those terms, right? Going back to the very simple example that we had here, we had list image files, right? And list image files, I mean, I guess it means one thing, but to be crisp, like I said, this is what the LLM's looking at, your description of the tool, right? So when Word says format, it's going to have a description for that tool, which is going to be a fairly long description, exactly describing what format does, right? It can change bold, italics, blah, blah, blah. It can change colors or whatever it is. It's going to describe to the LLM what that tool actually means in gory detail, right? That's what the tool is using. It's not using the word format. It's using the description of the tool format. And that description could be different in Excel, could be different in Word, if it has to be different. In like I'm imagining in a Paint application, formatting might be different, you know. So this is why this description field is very important. It helps disambiguate to the LLM. You're right. An LLM could misinterpret what format is, and if you're not careful, you have to be very crisp. LLMs only work with crisp information. You have to be very verbose as much as possible so that it understands your intent.
Thank you.
Yeah. This kind of interesting thing about PowerPoint slides, right? And in the interest of time, what I had done is, you notice these slides are all different. When I got to this slide, I actually had gone into Copilot and I told it to change. Uh, yeah, I just told it to change the slide, the format of the slide. That's why this slide looks a little different from the other slides. I just, I told it to make it more tech friendly or something like that. Yeah. And I told it I made some changes to the text. I said, update some of the numbers used for ChatGemini. I told you that. So all of that was done through just by me talking to Copilot. The whole presentation was created by Copilot. I just gave it a broad outline that I had shared with John a couple of weeks ago, and then it created most of it for me, and then I went back with it like through this Copilot interface in a little back and forth. Hey, change this. Oh, update that, and then it did all that, and that was it. Right? I don't have to actually edit the PowerPoint slide itself.
I gotta warn you, John. I think I know how I want to create the next Trends in Personal Technologies presentation. Thank you, Sujit.
Yeah. Once you get used to it, it's tough to go back. Let me tell you.
Yeah, I can imagine.
And image creation generation, I know we've we've done many on these before, so I'm not going to go there.
Very cool.
So we looked at the non-coding agents, right? We can briefly look at coding agents. Now I know there was some interest in that. Everyone's heard like Cloud Code, they've pretty much very popular. They've got a good sweet bench score that in other words they're able to generate code pretty accurately. Cursor, you can see some of the valuation. GitHub Copilot, I think, is probably the most popular. It's 180 million developers. I'm one of them that use it, and so that's that's something that makes our lives as code as easy. So I want to do a quick demo. How much time do we have? I don't know. I feel like we're almost running out of time, right? Should we wrap up over here, John? What do
No,
you think?
we got till 9:30 at least,
Okay.
as long as people will stay. But
Okay. What I want to do over here is, okay, I have a blank slate over here, right? So I want some ideas on what code we could write today. Give me something simple to write, and we'll write it right now. It's a blank project. It's empty. There's nothing in here.
Could I tell you, one of the things that happens if you select and copy equations from a page on the web and then try to paste it into Word, it pastes the equation as LaTeX. But you'd like it to convert the LaTeX to the same symbol format.
Got it. So you want a tool that will convert it for you? Is that what you're asking?
Yeah.
Okay.
That could be a product of the clipboard tool you're using.
Yeah.
You should be able to just ask the Copilot to do it in Word. No?
There's a difference between a paste special and retain the formatting or not retain the formatting. And some of the clipboard managers, whether it's Windows Clipboard History or CopyQ or Ditto or any of the other clipboard managers.
Maybe this is too complicated for now. How about just something that calculates, redoes a recipe for twice the size?
Okay.
Is that simpler?
Yeah. But where is it going? So let's think about where is it going to get the recipe from? Like we're going to want to point to a cooking website to get it. Like how are we going to provide it? Or we just say we're going to give it any content and it'll just
a chocolate layer cake.
Create a recipe double the size for a chocolate layer cake. Is that what you're saying?
Well, I'm thinking, if I had a recipe, and so find a recipe for a chocolate layer cake and make it for 16 people.
Yeah, see, but that's a good example of something that I feel I could ask Copilot to do, right? The general purpose Copilot, because it does require. Think about something that is, that Copilot can't do. Let's put it this way, like a Gemini can do. I think you can ask Gemini for that, what you just asked me. Is that correct? We can try it in Gemini, actually, or in Copilot, see what it says. I think that's something that Copilot can do. We can ask it here too, if you want. So, right, give me a recipe for chocolate. Let's see what it says. chocolate layered cake, right? Something like that.
Yeah.
Cake. But double the content. Is that double the number of servings?
Servings, yeah.
Now, okay, one thing I wanted to show you here, right? When we use the Copilot, there are some icons over here, right? Let's look at that. So this one is selecting the agent, right? And where is it? Show me that. Hold on. Oh, yeah, sorry. This is the kind of agent that we want to use. And there's essentially three agents that we use. There's an ask agent, which is typically just asking for questions, right? This may be one of them. Then there is a planning agent, which just creates a plan for us. It doesn't actually do anything. And then there is the actual agent, which will write the code for us, right? So from what you're telling me, how would you consider this? Would it be an ask or a plan or an agent? Should we try ask?
Yeah.
Yeah.
I think it would be ask because
Yeah.
it's just going to go out and suck up a recipe.
Let's see.
You know, double what?
Yeah.
If the original recipe was for 4 people and you wanted 8, well, what about if the original recipe was 8 people? You're not telling it. You're saying double the number of servings, but from what? You don't even have
Okay.
a starting recipe.
Okay, I'm going to say in the original recipe, double the servings in the. Let's see what it says. And the second box I want to show you here is the models, right, that you can pick from. And you can see all of the cloud models are there, the Sun and the GPT-5.5, right? You can pick a particular model, and of course, there's other models. So I can get all the Gemini models, Haiku, and this is the latest model from Microsoft, which was released just 2 weeks ago. It's supposed to be very good. And Maya, it's called the Maya model. Now, I use this mode called auto, right? The auto mode is very cool because it automatically figures out which is the best model to call for you, right? Because it can be somewhat, confusing as to figure out, okay, well, am I going to use it Opus 4.8 or 4.7? What is the difference? If you're a data scientist, you might go look at the model card and try and figure out, should I use it? I'm not, too interested in getting too fussy over that. So I just use auto, right? The auto means that Copilot is going to figure out which is the best model to use, right? The best model that I have at my disposal, which one it should use. It also gives you a little discount if you use auto. Anyway, so I'm going to use auto over here. Just I wanted to show you that. And there's some other settings over here with tools and all that. Again, we have access to tools. We talked about our agents only as powerful as the tools that they have, and you can have all these tools. Like I said, you can have tools that open the browser, you can have tools that edit files, you can have tools that call the web, have tools that run programs, whatever. It's all in your control what you want to do. Anyway, let's run this. Just ignore the MCP extensions for now. I can explain what that is later. I should just skip it. All right, we're thinking now. Here's what it said. I'm a coding agent focused on helping programming test chocolate layered recipe out of my area of focus. All right, so we did, but it is trying to be helpful. It's providing you some websites so you can go and look at recipes if you're a hungry programmer. Now it's giving you some other thing. Okay, I can create a recipe database. If you have a lot of recipes, it can create a database for you with a website, so you can manage your own recipes if you want to. Or I think maybe you were talking about this. If you have a file and you wanted to figure out what's in the recipe, you could do that too, or anything else code related. But it has to be code related. That's sort of what. And you'll notice that because this was a relatively easy question for it to answer, you can see the model that it used over here was the Cloud Haiku 4.5, which is actually one of the cheapest models you can get because it figured it didn't need an expensive model to answer this question. You know, it just used the least expensive model it could find, which is 1.6 credits, which is pretty low. I mean, I typically the queries I ask normally are in the hundreds of credits. Anybody else have any other thoughts, ideas, anything that you think that would be coding related that could generate some code for us?
Well, how about just saying hello world and today's date? Or today, hello world and the date 2 weeks from now.
Okay. All right. So in any particular language you want this written in, John? That you have preference? Pascal?
No, I'm trying to think of one. Actually, if you just write a command script or a bash script.
What was that, Sergey? You were going to say something?
Shell?
Shell script? Right.
Yeah.
A shell script that says hello world.
Yeah.
You want to put them in quotes?
And prints the date 2 weeks in advance, you said?
Yeah.
And prints the date to.
I mean, that is pretty trivial, but
yeah, no, it's good to see it go through the process. Oh, so I had it in ask mode, right? So that's why I didn't. It's telling. It's going to give me the answer. It's telling me how to do it if I were to do copy and paste. So remember we had put this in ask mode. I'm going to change it to agent mode and do it again. Okay, I forgot I had made that change. So
Well, but it gave you the script.
it gave me the script. You can copy paste it. But if I'm too lazy and it's a big program, you can just ask to do it again. And this time it's going to do the agent mode, right? So let's do it again. It should really create a file on the left-hand side there. You should see it create a file, like a .sh file or maybe a .cmd. I'm not sure what it's going to do. Let it figure that out. And now it wants to run the file to test it out, right? And one of the things agents, like I said, agents are meant to be very careful. They don't want to do anything in your computer without your approval. And so it's asking me, is it okay that I execute this? Because it knows a shell script, executing a shell script is a dangerous thing on anyone's computer. So it's asking you if you want to allow it. And you could say, I want to allow exactly this command or, allow all commands, right? So I'll just say allow all commands in this session.
I created a file.
Yeah. So it's testing to see whether it works, right? And it's obviously not going to work because I don't know if if it's going to change. Let me just see if did it work? Created two to-dos.
Okay, it shows you the output.
Yeah. Done. I've created hello in your book. So the script prints hello was prints so and it shows you it ran it and it's showing you what it did. Okay, so I can say keep. If I say keep, that file is created over there, and that's really the shell script. Sergey, does the shell script look okay?
Yeah. Yeah, that shows you how things in the date command work. But can you ask it which versions of Unix or Linux it would work on, or what shell it needs?
Yeah, that's a good question.
That looks pretty universal.
Should I use to run this?
Oh, it says up at the top, bin bash.
Yes, it's use the GNU syntax. So you have to use WSL or git bash, it says. So I could run. You go back here.
I was loudly talking to my muted mic, as usual.
Does that is that just okay? Does it pass your test?
I think you should get it to write tests for it.
That's not a bad idea.
Yeah.
Let me just paste it here. Let's check it out. I have to do chmod, right? I think.
You don't have to just
No?
do dot space name space file name
Space.
test.sh.
There you go.
Fascinating.
That essentially dot is a short name for source.
So that's what it is. I
So it
forgot
just
about
read
that.
the shell file. Yeah.
Yeah. Over here it tells you to do chmod and all, but I guess that's not necessary. Yeah.
Well, I can. You've asked questions. I mean, as I'm listening, it's like, so what language do I want this in? Oh, wait a second. What language am I familiar with lately? What should I do here? I don't want it in Rust. I don't want it in Go. But if I want to learn something, I might.
Yeah. If you're not sure, you don't have to tell the
Perl,
language.
Python, Shell,
it would ask
C.
you. Yeah.
Write it in C.
Yeah. To write this in C language. And it tells you to compile it with GCC thing here, right? And create that.
Well, but let's take a look at the code.
Oh, Sergey is not convinced. Okay. I got to say keep, so it will keep all the code. Otherwise, it'll ignore it.
Yep.
And
so it just does a simple printf, and then it allocates a time structure and calculates the time, and off it goes.
Yeah.
So let's do that again. Let's copy it. We test C. Paste it there.
You can just
I
cat
don't
it to
know
a
if
file.
do I have GCC? I don't think I have. Oh yeah, GCC test. Let's see.
Test.c dash o test. That's good.
And then
Built. /test.
there you go. Yeah.
Wow.
Boom. Looks just the same as the last time.
Can this write stuff that would be shortcuts on an iPhone? You know what a shortcut is on an iPhone?
Yeah.
I mean, it's pretty powerful programming.
So I actually using this, I wrote a phone for my Apple Watch and I downloaded here and I never programmed on my app. It created a Swift program and I have my own program over here called Wander on my Apple Watch. I don't know if you can see it, but it's basically an app that every time I walk my dog, I start to walk. And as I'm wandering or walking the neighborhood, if one of my neighbors happens to be outside and says hello to me, I can look at my watch and it tells me what the neighbor's name is because it knows where I am in the neighborhood. It knows I am next to that person's house, and it reminds me that that's Joe or that's Caroline or somebody. So I say, hi, Caroline, and they're always amazed how I know their name all the time. But it's because I have entered all their information on the watch, and it's tracking me as I'm walking along the neighborhood. And every time I look at my watch, I'll be, okay, this is Henry.
What language did you write that in?
The only language I think you can enter the iPhone is Swift. That's the native language. It's called Swift.
Oh, so you actually wrote a program in the Swift
I didn't write
language.
anything. The Copilot did it. I gave it all the instructions. I gave it very detailed instructions, which were 2 pages long on how I wanted this written. Just text information, English instructions on what it should do and what it shouldn't do.
Wow.
And it created the
I
the
thought the iPhone was highly restricted as to what you can deploy on it.
No,
But
I have I have an
saying,
I have an Apple developer account. So I
oh,
was
okay.
yeah. But even without a developer account, the free developer account, you can do it. You can deploy programs to your iPhone or your watch. The only restriction is that the programs expire in 14 days, and you have to redeploy them every 14 days. If you have a
So,
developer program, they stay forever.
so back at your agenda,
Yeah,
where are we in the agenda?
good point. We're over here, coding agents, running how to write code. That's where we are. And there was one more area for custom agents, right? Things like OpenClaw and things like that. I don't know if that was the one place we wanted to go. If do we want to go there, or do we think this is enough for today?
So
Well, I think the idea, what is OpenClaw?
Does anyone know, where they can give other people a chance
Well, I
to
know
say
that
it?
OpenClaw was deprecated. He closed that off, replaced it with something called Crush, but Crush doesn't work very well. And so if you want to put it into VS Code, there's something called Cline, Cline, that replaces Crush. But all of these things are, what they're doing is an open source agent framework. So it's the thing that goes between the language model and the agents.
Yeah. It's basically a general purpose agent, right? Is what it is. You can think of it. It just has Copilot is a general purpose agent. OpenClaw is another instance of a very general purpose agent that can do a lot of things.
So
It has a
Copilot and OpenClaw or Crush or Cline are equivalent in some way.
yeah, they're all agents.
sure, they're all agents.
Yeah, they're
So
all
those are
different forms
the
of
agents.
yes.
Yep.
And these
Agent is a guy that goes between you and the LLM. And it might know how to do things or it might not. It might just show you a web interface, or it might include tool use, or it might include a persistent loop like OpenClaw does. OpenClaw is literally just pound the LLM until you get to the goal. It is just
well,
an agent loop.
well, and there's another sort of extension I would add into OpenClaw is that, or these other types of agents like OpenClaw, is that they run permanently on your computer, right? Now, it's not that they are doing things on your computer all the time, but you can uh, set up various tasks, recurring tasks for them to keep working on, right? See, when you use Gemini or ChatGPT or Copilot, right? It's a task by so you give it a request, after a minute it gives you a response, we're done, and everybody goes home, right? Nothing is there. OpenClaw and all, it's permanently on your computer. It's there all the time. You set it up to do things. It could wake up at 12:30 in the night and do something because you asked it to go and transfer, $20 from your checking account to your savings account at that time, and it would do it. But it has to be running. That's the thing. It needs a presence to be running all the time. Now, it's going to use the LLM to actually do the work because it's going to say, I have this tool called, a bank transfer agent or a bank transfer tool. And the LLM's going to say, okay, yeah, call the bank transfer tool and tell it to transfer $20 from this account to that account. And then the OpenClaw is going to do it for it. So it's the same concept of tools, agents, LLMs like we talked about. OpenClaw is running all the time, right? So OpenClaw has gotten a lot of bad press recently because apparently it could do all sorts of bad things on your computer, or people were never sure. It's open source. You could go here and look at all the code if you wanted to. But what Microsoft did is Microsoft collaborated with the guy who started OpenClaw, and they created a program called Scout, Microsoft Scout, which is a restricted version of OpenClaw. It's just very safe to run. In fact, I am running it on my computer here now. I have Microsoft Scout running over here. I don't know if this gets bigger. And you can see over here, there's this thing called automations, which is pretty cool, right? So let me kind of show you what this automation looks like. And you could create a schedule. So I say every 2 minutes, right? And this is the power of it. I just say, oh, go get get a count of my unread emails from my Hotmail account. That's all you have to say, right? You never give it like much more details than that. Now, of course, the first time you run it, it'll try to find a tool that can handle your Hotmail account, and that tool will say, okay, I need to authenticate and all that. So you do all that one time and you set it up. But from a user perspective, that's all I wanted to say because that's what I want. I want to get a count of my unread emails from my Hotmail account, right? That's all I have to do. So now if I go ahead and run this, right, and we can look over here. Let me see, when did I run this? This was I run it.
3.
Yeah, so I have three emails in my account. Let me double check. That was from earlier today. Let me see. I'm going to wait for this thing to run again. Did it run just now? It hasn't run recently.
Is Microsoft Scout free, like Copilot is free?
I don't know the answer to that question, but it was released very recently, so it's probably free for now. I don't know if it's going to be free like forever. It might be free under some sort of licensing. Like maybe if you have like the Microsoft 365 account. Yeah, you see it's woken up because 2 minutes past it's processing, it's running this tool that it had access to, and yeah, it's got the answer 3, right? So it's still 3. After 2 minutes, it's still going to run it again. It just keeps running. Every 2 minutes, it's going to wake up. Let me just go into my Outlook and double check that and yeah. So the one which was originally highlighted was the one on top, which is now being read, second and third. So there's 3 unread emails. Yeah.
Sujit, you want to check your agenda and see how you want to proceed?
Yeah. So that was kind of, I think the last of it was just showing you OpenClaw and Scout and how the tasks work and things like that. Yeah, I recommend you take a look at these things because it really can do like some interesting things over here. I wanted to show you one more thing that was pretty cool in OpenClaw. In Scout, actually. It's still running my things over here, but like I think one of the things I wanted to do was, get all the list of meetings of the BCUG of New Jersey and add them to my calendar. Check with me first before adding them.
Spelling error, YCUG.
It doesn't matter.
Let's see what it does.
They're pretty smart about that.
So you can see I've given it a task which does involve actually updating, updating my thing. Now, again, it always wants to be careful. It asks you for permission to a lot of things. I'm going to say allow for this session, but you could be very precise and not give it carte blanche access. You'll see some interesting things that it does now. I'm going to put this over to the side here. Again, allow for this session, allow for this session. Let's just see what it does. Allow for this session. So as you can see, it's found these tools it's using. It's running the tools, right? Allow for this session. It's actually going to fire up the browser for me on my computer, and it's going to actually manipulate the browser. Now, take a look at this.
Oh, it does it through the browser UI? Interesting.
Yeah. I used to just allow this.
So, Sujit, what would you define the word agentic as meaning?
Knows how to use tools.
Yeah, it's something, what makes an agent unique is that it can actually take actions on your behalf, right? As opposed to just an LLM. And it uses to get those actions to do those actions, it uses a bunch of tools. You can see that it has found the 4 meetings and the Linux meeting, general meeting, the PC roundtable, all in Zoom. Yeah, so I can add them to my calendar, which I want to, but that's why I asked it to check with me before adding them. So this is an example of what, Scout or some of these general purpose agents can do is they can make updates to your things on your behalf, automatically.
So is Scout is a personal agent. It's an agent.
It's an offshoot of OpenClaw.
And on the other side of that, there are tools. And on the front side of that, so to speak, there are the chatbots or the large language models.
Correct.
Now, be careful. A chatbot is just a user interface between you and the language model, right? Language models sit in the back. The agents interact between you and the model and the tools, right? It's the agent that handles the traffic.
So what is the thing that the agent talks to, if not a chatbot?
It talks to a language model on one side, and then it also talks to tools when the language model requests them.
Does a language model have to be inside something?
Oh, sure. I mean, there are model runtimes and managers and all kinds of layers there.
Yeah, the language model could be something like this, like the Olama hosted model, right? That's the simplest running on
So
your
something
computer.
has to host the model.
Yeah.
Well,
and the agent talks to the host.
The API that the model exposes. All models have a fixed API, and it's pretty standard, the API nowadays. That's why you can switch from model to model pretty seamlessly. You just talk to the API and say, I want to use this model, and here are the parameters, and give me the results. And that's basically it. You don't need to know what's underneath the
API,
hood, so to speak.
Right.
Yeah.
The model runners and the model runtimes will provide typically an HTTP API that you can use. So you can literally use commands like curl on the command line to talk to the model. And so literally you can be an agent at the command line using curl. You can literally use curl and tell the model that you know how to invoke these tools. And then the model will ask you to use the tools, and you're expected to provide the output of the tools to the model. You can be the tool. You can tell the model, for example, that you know that you have a weather tool. And when the user sends a prompt that says, go get me weather in Tokyo, the model can tell you to use the tool to get the weather in Tokyo. And you can just go look it up on the web and format it as JSON and give it back to the model.
Oh, and the language that they speak here is JSON.
Well, JSON is just the containers in which the language gets passed back and forth. But the language that they speak is English or French or any Russian or anything else you want. Most of these models are capable of dozens of human languages. But the communication format is JSON, and there is a defined, well-known JSON set of fields. Those fields that we were looking at with roles and the tool results and all of those, that's the JSON format.
This is JSON, but you can see that's just what's really important are these, just the contents of it here.
But that's the payload.
Yeah.
Right. And the model understands the payload.
Yeah. This is what's important. It's just the English text that you pass in. Do you duplicate images? That's all it's saying.
So the big takeaway here is that the models are capable of taking pretty approximate English and turning it into hard requests to the tools that are providable, that can be provided. And therefore it can figure out when to invoke the tools, and will ask the tools to provide the information.
Yep. And you saw that work across different, like Office, the OpenClaw, the coding agents. It's the same process that's used everywhere. It's the model is the concept is the same for agents.
It's a
And there are
brilliantly
lots of free tools on GitHub and other places.
You can implement a tool anytime you want. Just ask an LLM to implement one. If you know what you want the tool to do, you can just generate the code for it.
I mean, everything that I showed you today.
A tool is something that just knows how to execute a request that is sent from the model, right?
Yeah.
A tool that, in this case, the tool that we're looking at is literally, its name is list image files, and can we go back to that JSON example that we just saw?
Yeah.
The one that defined the tool. So it knows how to list image files. Yeah, there it is. And and it has these properties that it needs a folder path.
And here's the implementation.
You just give it a folder path, and boom, off it goes.
Yeah.
And it expects you to return the list of files. Right? And folder path is required. And model understands that.
And John, this whole sample I just built it using Copilot agent. I just told it to create a very, very simple Python application that describes this concept, and I gave it a few instructions, and it generated.
Notice that in this case, the tool is actually returning more information than it promised. Like it's returning a count, right?
Yeah.
And it's actually echoing a folder, and it's returning, okay, that may be part of the protocol, I don't remember. But surely the count is not. Right? So it's just returning extra information, and the LLM is likely to ignore that.
Yeah.
I think there's a lot of interest in this subject. I was wondering if we could write stuff, traction stuff for both our members, and absorb new members by going more into having some AI workshops.
Well, I think there are people who are interested in knowing how to do this, and there are classes that people pay for it. But if we were doing different things, I think, yeah.
I mean, I'm still on the early learning curve. I'm playing with it for a while, but
yeah, the one thing I'll just say in closing over here is that, just looking ahead, like, I mean, this is even now, this is why things like Scout and all are, the important thing with LLMs is that you have to have certain guardrails on it, right? Because you don't want it to generate things that are bad, obviously. Yeah, even agents, you don't want to do things that it's not supposed to do. So there are all these guardrails that you put in so that it doesn't wipe out your computer or doesn't steal your files, and that's always a concern. So, getting your agent from a reliable source is very important. Just, doing AI safety, making sure that, it is not generating harmful content and all that is all very important. And sort of what's next is that we're building all these agents. You saw me demonstrate a whole bunch of agents. Think about if all these agents were to talk to each other, right? So Scout is a good example of an agent that can talk to Word, Excel. And so we talk to an agent in Excel, talk to an agent in Word, talk to something on the web, and combine all of it together to literally, coordinate a whole bunch of tasks, like, create my entire plan for next quarter, so it's going to essentially automate the whole process for you. And you set it up and you say on the first of every quarter, you run this set of tasks. And when you come to work in the morning, you have your entire information for your next quarter ready to go.
Yep. I used to work with a guy back in the 70s that said like he wanted to have a Monday script to come in Monday to work Monday morning and type Monday, and it would do all the work for him. We're
Correct.
getting close.
Almost there.
Yeah. But you know what? Anytime that you have guardrails, you have turnstile jumpers. And there are people out there making a sport out of breaking into LLMs and
Sure.
convincing them to violate their guardrails.
Yep.
So there's a lot of fun out there to be had.
Wow. And you can hear
And a
that
lot of risk.
the government is asking for reviewing the releases of models like Anthropic and Mythos and the use of these things to control drones and read maps and do things like that. And
Yeah.
also, obviously, it can track a price of a stock on the internet and buy and sell for you. I mean,
Sure.
we talk about
If you trust
super
it.
fast trading already. When this thing starts going, it's like, holy mackerel, traffic jam. And
We've had program trading for years and years and years.
Yeah,
Yeah.
they have
Now-
what's called circuit breakers on them. Now we need a whole new class of circuit breakers, maybe.
Indeed, yeah. So one thing I'll tell you what agents and LLMs cannot do is they can't do things that are real time, right? They're just not there yet. All these models take seconds and minutes to run. So we're very, very far from the time when these things can be used for things like trading, because that requires,
Well, it depends.
millisecond response time. You need custom models for that. You can't use the general large language models for that.
But
and
it
so
depends
this
on,
is
on
why
what your resolution is, right?
Yeah, yeah.
If you're trading sub-second, if you're trying to catch sub-second trends, it's one thing. If you're trying to catch trends that are in terms of minutes or hours or days, it's a totally different one, right?
Indeed.
But that whole financial picture is, there's so many people that have been trying to figure it out and manipulate it and predict patterns, and of course some succeed and some fail, and
Yeah.
some succeed for a while and then fail.
Yes.
which is otherwise known as liquidity.
So this brings us to the end of your presentation, Sujit. And
Yep.
I
If there's
trust
any
that
questions, you can please.
you would take questions if they were posted in the discussion forum, for example.
I will.
So people can get to you easily. They can find you in there. I really appreciate you presenting this and putting this together, even with the help of AI and whatever else helped you. But that makes it just all the more amazing. And thanks for chiming in, Sergey. I
Sergey
appreciate
was my co-pilot on this one today, so I appreciate that.
I'll wear the hat. Thank you. I appreciate it. Not that I deserve much credit here. I'm just good at asking ChatGPT.
All right, yeah, good questions from everybody. Thanks for being an interactive audience. Yeah.
Thank you very much. Great job, Sergey.
That's good. Thanks,
Really appreciate it.
I'm more knowledgeable than I was yesterday, but still not as smart as I could be tomorrow.
That's it.
That's
always a future.
That's the way to look at it. Yeah.
We will be digging into this for a while to come.
I'm sure. Yep.
Yep. Please post any questions, or if you find out something interesting in this topic,